Hello, everyone. Thanks for joining. Today, I would like to discuss one of the most commonly faced issues in the SQL Server world, and that is TempDB contention. We will take a deep dive into how to identify when contention occurs and how to resolve it. And I think I must say this, this is one of those performance problems I learned the hard way in my earlier years as a database administrator. So I want to make sure now you have all the right tools to handle this smoothly. And about myself, I'm a SQL database administrator. I've been working for 10 years. I work mostly on the server and database operations, trying to keep the lights on. I mean, the green lights, obviously. And I love to focus on the internals, the working of the SQL Server engine, and thereby improvising the performance. These are my core areas of interest. And I love to participate in the New England SQL Server group, that is our local user group, and in SQL Saturday Boston, and various online learning communities. They've all been very helpful. And I work a lot on AWS Cloud, and I'm an AWS certified solutions architect. And I won an award at work, and that is Rookie of the Year 2023. And today's session will cover the intermediate level concepts, and I will be skipping the basics, assuming that the attendees already know the basics of TempDB. So the agenda for today would be the uses of TempDB, what are the different types of TempDB contention, and how to identify contention when it occurs, and what are the different ways to resolve it. What is the need to learn about TempDB contention now? So there are always multiple operations competing for TempDB resources. So when all those operations are competing for the resources, that creates a slowness in the system. And to troubleshoot that slowness, it is important to understand what TempDB contention is. And speaking about concurrency management, at any given point of time, if you look at the production server, there are always thousands of concurrent transactions running on TempDB. And to manage them all effectively, it is very important to understand how TempDB contention occurs and how to spot it and fix it. So what runs on TempDB? We have three categories like user objects, internal objects, and version stores. User objects. These are the objects that we create as users, local and global temporary tables or temporary stored procedures or any table variables. And you can see them all in sys.allObjects catalog view. But in internal objects, these are the ones that SQL Server creates. These are work tables and work files that are created by the SQL Server to store the intermediate results for hash joins, pools, cursors instead of triggers and various other things. And we can't query or see them. Well, you can see them in the execution plan, but we don't create or see them. And the third type is the version stores. This is used for the row versioning if you see for optimistic transaction isolation levels or online index operations and after triggers. So TempDB is heavily used for these three categories, and TempDB, as we know, is a shared resource for all user connections, and no wonder contention occurs on TempDB. And if we take a look at the three types of contention here, the first one is object allocation contention. That's a DML type. And the second contention is the metadata contention, which is of the DDL type. And the third one is the temp table cache contention. We will take a deep dive into each of the contention type, see how it occurs and how to identify it, and also how to resolve it. So the first type is the object allocation contention. So under normal circumstances on any user database, you have insert, update, and delete operations running. And those operations, they need a latch on PFS, GAM, and SGAM pages to allocate space for the objects. But in TempDB, there are constantly numerous insert, update, and delete operations frequently running. And all those operations, they need a latch on PFS, GAM, and SGAM pages to allocate objects. And those latches that are waiting, they cause the contention. To look into it in detail, let me show you this image of the TempDB data file. Consider this tempdb.mdf. And these are the first 8 pages that are the same in any data file on any database. So page 0 is the file header. It contains the header information. And page 1, 2, and 3, which are highlighted in green, are of our interest. So we're just going to be talking about those 3 tracking pages. So these 3 pages are the PFS, GAM, and SGAM pages, and they are tracking pages. And what are tracking pages? They are used to track the status of the data pages. And SQL Server uses these tracking pages to find out which page is free or which page is allocated and which page is not allocated. Now we will see why these 3 pages are used and why the latches are needed on these 3 pages and how contention occurs because of these 3 pages. First is the PFS page. This is an 8 KB page by itself in a data file. This page tracks the free space available for each page. So if you take a look at this page image here, you can grab this by doing dbcc page. And let me zoom in here. Yes, I just did. All right. So file ID 1, page 0, and this is file ID 1, page 3. Page 0 to 3, it's allocated. It's 100% full. And if you look at page 4, page 5, it's not allocated. It's 0% full. So this is what the PFS page information is about. It contains the allocation information and the percentage information, how much of a page is full. If you, for example, look at this one, it says 50% full, page number 32. So it contains all this information, and that is why the latches, so the operations need a latch. A latch means a lightweight lock. So operations need a latch on the PFS page to know how much of a page is full or which page has space. And the second thing is GAM page. This is the global allocation map. This page tracks if an uniform extent is allocated or not. What is an extent? 8 pages. And what is an uniform extent? All 8 pages have the data of the same object. And if you look at the image of a GAM page, let me zoom in again to show you the allocation and deallocation here. So you can again get this by doing dbcc page. So this is file ID 1, page 0, file ID 1, page 150,608. So if you see all these pages, they are allocated. And if you look at this page 150616, see how it says not allocated. So again, all the operations, they need a latch on this GAM page to know which page is allocated and which page is not allocated. And the same thing now for SGAM too. But what this page does is it tracks a mixed extent is allocated or not. Mixed extent means now all 8 pages, they have data of different objects. And if you look at this page here again, this will be from page 0 to page 147648. It's not allocated, and the other page is allocated. So again, all operations, they need a latch on this SGAM page to know which page is allocated or which page is not allocated. So if you look at this, you see how those operations, they need to acquire a latch on PFS, GAM, and SGAM pages to know the allocation status of the data pages for the SQL Server to allocate the objects. And so how does that cause contention? Let's take an image of TempDB.mdf. You see this, how multiple transactions are just hitting on this one data file, and they're all waiting to acquire a latch on PFS, GAM, and SGAM pages. And that causes contention. And we know that page 1, 2, and 3 are always PFS, GAM, and SGAM page in any data file. And for every 8,088 pages, you have a new PFS page. And for every 511,232 pages, there will be a new GAM page followed by SGAM page. And why that specific interval? I've written in the blog post explaining why the PFS, GAM, and SGAM pages appear in that every specific interval. Okay, now that we know how contention occurs, let's look into how to identify it when contention occurs. You will see update page latches or shared page latches on PFS, GAM, and SGAM pages. So how do you find that out? 2 here is the TempDB database ID. And this file ID, it can be MDF or NDF file, and how many ever number of files you have in your TempDB, that will be the file ID here. And this is the page number. You will have either 1, 2, and 3, which is the PFS, GAM, SGAM pages, or multiples of 8088 or 511232. So you have page latches on PFS, GAM, and SGAM pages, then you know it's object allocation contention. So why is it called object allocation contention? Because to allocate the objects onto the data pages, it is waiting to acquire latches, and that causes contention. So that is why it is called object allocation contention. And I don't use perform counters that much, but if you're someone who uses perform counters, you can use these counters to set up and detect the detect the contention, I mean. All right, and okay, so now that we know how to identify it, how do we resolve it? Let me bring that picture back again here. So where multiple transactions are hitting on that data file, causing contention. Here we have only one data file. Imagine you have multiple data files. What happens? Now transactions are spread across multiple data files. What SQL Server does is it round robins across the data files. The allocations get spread, and that's how the contention gets mitigated. It not only round robins across the data files, it also round robins across the PFS pages starting in SQL 2017. So you see how the allocations are going like this. So it goes 1, 2, 3, and 4, and then 5 comes here. It does not do all the PFS pages in the data file itself. It goes across and then round robins like this. So this helps in mitigating the contention as well. So round robins across the data files and also with the PFS pages. And for up to 8 logical processes, you create 8 TempDB data files. Imagine you have 4 processors, then you create 4 files. If you have 6, you create 6 files. But if you have anything more than 8 logical processors, like you have 16 or 32, what you do is start with 8. Always start with the minimum of 8. Check for the contention. If you see contention, then add 4 more. You always increase in numbers of 4. So you add 4, you have 12 now. Again, check for contention. You see contention, then keep adding 4. So somewhere at a point, you will be able to see that contention is mitigated. You may not be able to resolve this contention completely, but you should find that sweet spot where you can mitigate this contention. And when you create these new data files, make sure that you create them with equal size and equal auto growth. Why? Because SQL Server follows this proportional fill algorithm where it proportionally fills all the data files based on the empty space. So imagine you have a new data file that is bigger than the other data files. So what happens is all the transactions now, they're going to be hitting that new data file. It becomes a hotspot and that causes contention, which is exactly what we don't want. So it is very important to create those new files in additional numbers of 4 and also in equal size and equal auto growth. Now let's look at this enhancements by version. So if you're on SQL 2014, you need to turn on the trace flags 1117, which I believe is it uses the full extents, the uniform extents instead of the mixed extents. And 1118 is it auto grows the files equally, so that helps with the performance. And that is with the 2014 version. And with 2016 and onwards, you don't need to turn on these trace flags. This behavior is already set up in the SQL Server, so we don't need to manually enable this at all. In 2019, there was a good improvement with the contention where you see how we saw contention on PFS, GAM, and SGAM pages, right? So 2019 addressed the PFS contention, which is, so all the exclusive latches have been updated with the shared latch. So you should not see contention on PFS page in 2019 version. And in 2022, this has a very good improvement because the two things that we were lacking is that GAM and SGAM pages to address the contention. So now these two have been updated with a shared latch instead of an exclusive latch. So in 2022 version, you will not see contention on PFS or GAM or SGAM. And that means there's no object allocation contention on this version. With that being said, you should still follow all the best practices across all the versions. So now we are done with the first type of contention. Now we are going to take a look at the second type of contention, and that is metadata contention. Under normal circumstances in any database, there are some create, alter, and drop operations happening, and those operations, they need to acquire a latch on the system object pages. And in any user database, can you think like you're not constantly creating or dropping user objects, right? But in TempDB, we are constantly creating, dropping, altering the temporary objects. So what happens? All those operations, they need to acquire a latch on the system object pages, and that causes contention. If you take a look at this image, for example, you see how all the delete operations, they are just hitting that system object pages, and that causes contention. Okay, now we know how this metadata contention occurs. Let's see how to identify it. You will see page latches here as well, but this will be exclusive page latches or shared page latches, and that will be on the system object pages. In the object allocation contention, we saw page latches on the PFS, GAM, and SGAM pages. In metadata contention, you will see page latches on the system pages. So again here, 2 is the database ID. This is the file ID, the TempDB data files, and system pages will be any of the system objects. So once you see page latches on these system pages, then you know it's metadata contention. So why is this called metadata contention? Because you're seeing contention on the system object pages. System objects are nothing but metadata, right? So that's why it's called metadata contention. And if you use performance counters, again, feel free to use those counters to set up and find out the contention from the rates here. And how to resolve this metadata contention. If you take a look at your query, you can see that sometimes there might be temporary objects explicitly dropping. So please do not drop the temporary objects explicitly. Why? Because once you are dropping, then that means you're again waiting to get a latch on the system objects. So we can prevent the page latches from happening by not explicitly dropping them. Anyway, when the session gets completed, the temporary objects are going to get dropped. So you don't have to go in there and explicitly drop them. And same applies to truncate tables. It's metadata, so it's again goes and waits for the page latch. And caching temporary objects is very, very important. So when you create a temporary object or temporary table, and if you want to create an index for that table, create the index in line with the table definition, like inside the table definition structure itself. Don't come outside of the table definition and do, create table, create this index, so once you create the index outside of the table, then that means you're altering the temp table DDL. And once you alter the temp table DDL, then it won't get cached. If it doesn't get cached, then we cannot reuse it. So make sure you don't alter the temp table DDL, only then it will get cached and it can be reused. And also remember to create these temporary objects inside of a stored procedure or wrap it up in a function. Don't create the temporary objects in ad hoc batches. If they are in ad hoc batches, then it won't be cached. So make sure you create them inside of a stored procedure and it will help it cache and it can be reused. So doing this will reduce a lot of page latches and that will mitigate the contention. So once you're done with tuning the query, then what you can do is there is another feature called in-memory TempDB metadata feature starting SQL 2019. So what this feature does is it moves all the heavily utilized system objects to memory optimized objects. So when it becomes memory optimized, what happens? All those tables become latch free and lock free. And that way contention can be reduced. And if you're on SQL 2019, be sure to be at a minimum of CO2 because CO2 moves all the needed objects, including these two system objects. Because I think CU1 and the plain version doesn't move these two objects, then you're still going to see page latches. And it is always good to be on one of the latest CUs. And this option is off by default. We have to manually turn it on. So we saw two types of contention now, and this is the third type of contention, which is the temp table cache contention. And this is about contention on cache for the memory objects on the temp table. This appears due to the inefficient usage of large hash tables, and you would see something like CMEM thread or source cache stores in lock waits. Then it could be a case of this contention, and there's nothing we could do about it. This is just like an FYI I'm giving to you because you have to open up a case with Microsoft customer service and they will help you out. All right, so we did see the three types of contention, and what I would like to do now is show you the demonstration of the object allocation contention and the metadata contention. Okay, I'm in. All right, so first I would like to show you the contention, how contention occurs and how we resolve it on 2019 version, and then I'll show it to you on 2022. All right, so this is 2019. Let's check the version out. 2019 CU24. CU25, I believe, is the latest. We are good on CU24. And how many processors do we have? 8. So we should have 8 data files that comes with the install. All right. So here is the stored procedure that I'm going to be creating. This is borrowed from Klaus Askenbrenner. His videos and blogs are great. And I got the stored procedure from his blog, and I modified it according to a demonstration to show the contention. I'm using this test database, creating the stored procedure here, which will create a temp table with 3 columns, and I'm creating the index inside of the table definition and inserting 10 records into this table. So let me go ahead and run this. Okay. And I'm going to be using this Postgres utility. This is a free Microsoft command line tool. You can use this utility to generate a workload against the server, so you can troubleshoot the issues. Also, I think it lets you to use the trace from a real production server, so you can use the trace on the test or dev box to generate the production workload, and you can troubleshoot the issues. So I will be running this query here, Postgres executable on server 2019. This will run the execute. This is database name, schema name, dot the procedure name on 50 threads, which is on 50 concurrent connections for 1,000 times. So I'm going to be running this and check the contention. Let me show you the contention query that I'm going to be using. And this is from the Microsoft blog. So if you see, what this does is it is getting all the results from DM exec request. This displays the currently active request, and this is a DMF, dynamic management function, DM exec SQL text. So when this used in conjunction with the DMV, which has a SQL handle, then you can get the SQL text of what query we are running. And this FN page rest cracker is a new function in 2019, and DMDB page info is a new DMF that is a replacement of DBCC page. So that's also in 2019. So you use these two functions in conjunction, you will get a lot of details from the page, like page resources, ID, file ID, and what object is in there. You can get all that information using these two functions. And I'm filtering this by page latch because as of now, we are only interested in TempDB contention. So if I hit this off, there's nothing running, so it's just empty. Let me go ahead and run this Postgres query to generate the workload. Postgres exe 2019 version. Let me hit this off. Okay, so threads created, execution is started. Let me run this. Okay, so what do we see now? Page latch, exclusive page latches on TempDB database ID is 2. File ID 9, and page number 8. What does this page 8 have? Sys allocation units. Okay, so this is a system object, which means metadata. So you see page latches on metadata. So this is metadata contention. Let's scroll through. Okay, so all you see is metadata contention. Okay. You see the different objects here, sys rs call, sys call parse. Okay, so there are a few system objects here that we are seeing for metadata contention. And how do we resolve this metadata contention? First thing is you take a look at your query, make sure the table is cached. So how do we check that? Now the temporary table, yes, it's wrapped inside a stored procedure. Good. And then you have the index created inside the table definition. Good. We are not altering this temporary table outside of the table definition. Good. And we are not explicitly dropping the temporary object. Again, that's good. So we have reduced a lot of page latches by writing this query. I mean, by having a good by writing the query in a good way. So this is good. And what is the second way we can mitigate the contention? Is by turning on the in-memory TempDB metadata feature, which is this one. So if you do the server property, is TempDB metadata memory optimized? You will see that this is disabled because it is not on by default. We have to turn it on. And we can use this query here, alter the server configuration and set TempDB metadata on. But I would like to tell you that for this to take effect, it needs a restart of the SQL service. So talking about SQL restarts, well, if it's if it's a production server, you need to align with your application team, get a maintenance window, and then perform the restart. If it's a standalone instance, that's fine. It's just one node. Imagine you have failover clustered instance setup or on an AG setup, then you have to enable this feature on active and passive nodes and on primary and multiple secondary nodes. So make sure this configuration is consistent across all the nodes. All right, let me go ahead and turn this on. If you check this again, it will still be 0 because it needs a restart. Let's go ahead and restart. When you restart, please do it from the configuration manager for standalone instances and use the failover cluster manager for the clustered instances. All right, let me check this again. It should be 1. We enabled it. Good. And so what does this mean, memory optimized? I told you that all the heavily utilized system objects will be memory optimized now. So let's check what objects have been memory optimized. If you see this, all objects joining with the memory optimized, we can take a look at what objects have been memory optimized. Okay, you see 12 objects here. Now all these 12 objects are memory optimized, and that means they are latch free. You see here when that query was running, all these had latches. Now next time we hit this query off, we shouldn't see these latches on these system objects. Let's go and test it out. Okay, let me run this. The same script, I haven't changed anything. I just enabled this feature here. Okay, now we don't see exclusive page latches on the system objects. That's good. We got rid of metadata contention, but it appears we are having a new problem here. Update page latch on TempDB database ID 2, file ID 5, and page number 2. Well, this must be familiar to you. So page 2 is GAM page. Page 1 is PFS, page 2 is GAM, and page 3 is SGAM. So we have page latch on a GAM page, and that means it's allocation contention. You see allocation contention. Let me scroll through. Okay, so it's all allocation contention. We were able to get rid of metadata contention, and that's good. Okay, so let's focus on the allocation part. How do we mitigate this one? We should increase the number of data files, and that will spread the allocations across, and we should see the contention getting reduced. Let's go ahead and grab this script here. So how many data files do we have? We already have 8. So what I'm going to do is increase 4 data files, add 4 data files, and equal size equal file growth. Let me add this. Okay, so now we should have 12 data files. Let me just verify. Okay, we have 12 data files. What we're going to see is, let me go hit this script again, the OSHS one. So there's no change in the script. It's exactly the same script. The changes that we have done to the 2019 instances enabled the metadata feature, and that contention is gone. And now we have allocation contention. So we added 4 files. Let's see what happens now. Okay, we don't see anything now. Let's keep checking. Okay, we see something. Yep, this one. Okay, probably this, we have been able to mitigate it, but not completely resolve it. So it looks like there's a couple here and there. It's inconsistent on 2019. You see, we still see the page latches just for the allocation contention. Okay, so do you think adding 4 more files will help resolve this contention? Let's try with the perf one, because on SSMS, by the time we hit F5, we might miss a few page latches, right? So before adding any more files, what I want to do is try perfmon for 2019 instance. I just have batch request and page latch waits on this one. So let me turn this on and hit this off. Let's see how the page latches are. You see the throughput going up because those are the number of threads and the connections that we have. Okay, we are interested in the red part because these are the page latches. 1,300 page latches as of the second. Okay, let's see. Okay, so this is the graph we have for now by adding 4 files. So we were able to mitigate it, and this is the graph we have now. What I want to do is add 4 more and see if this reduces. I think it should be done in a few seconds. Yep, all set. Okay, let's add 4 more files and see if this graph goes down. If it goes down, then we can add another 4. If it's the same, then we'll just leave it at that point. Okay, so let's go ahead and add 4 more, 13, 14, 15, and 16. See this. And how many files do we have now? 16 files. Okay. Come on, let's start this and let's kick this off. So with 4 more files, do we see any difference? Let's check it out. All right, the page latch. Yes, there are page latches, 1,300 latches, pretty much the same like before. Okay. I don't think there's any big difference between the last graph and this one. It's been the same. So yeah, I'm going to stop it at this point. Adding more files is not going to help because you see we added 4 and it didn't help. Okay, so I think this is good. So what did we do now to reduce the allocation contention? We started with 8 files. We added 4 files and that mitigated the contention. And there was still a little bit contention. So we tried adding another 4 and it didn't make any difference. So this is how you find that good spot of where you have to stop adding more files because the contention is still the same. You will be able to mitigate it to some extent. All right. So this is 2019. I would like to show the same demonstration on 2022 and check out how contention is on 22. So basically it's the same thing I'm going to be running. Let's check the version. 22 version and CU10. I believe CU12 is the latest, so we are good here. 8 processors. So we should have 8 files. That's good. It's the same procedure earlier I mentioned, which I borrowed from class. So it's exactly the same thing. So let me go ahead and run this procedure. Okay, and okay, so this is the OSTRES utility. The only change in the script is the 22 version here that I have. Okay, so before I hit this off, I want to keep my contention script on. Okay, so this is the same contention script. Same script that I used to check contention on 2019. I'm using the same thing on 22. So let me go ahead and run this. Let's find out. This is on 22. Okay, started. All right, page latches. Here we go. Exclusive page latches on TempDB, file ID 1, page 189. What is page 189? Sys allocation units object. So this is metadata. And page latches on metadata is metadata contention. What do we see here? It's all metadata contention. All right, and how do we resolve this? We know our query is good. So we are going to try the in-memory TempDB metadata feature that we turned on in 2019. So we can turn it on 22 as well. As of now, it's 0. I'm going to turn this on. And this needs a restart for this parameter to take effect because this is not a dynamic parameter. So I'm restarting the service and it should be up in a few seconds. All right, let's do this. Okay, it's turned on now. And just like in 2019, you should see all those 12 objects being memory optimized. So all these should be latch free, which means we should not see this now. Okay, so let me hit. You see the errors here. It's because I restarted the service without stopping this. That's why. Okay, and 22 version. Let me hit this. Check for the contention. Ooh, everything is gone. We don't see metadata contention. Yes, because we turned on that feature. Good. And we don't even see object allocation contention. Did you notice? We don't have any page latches on the GAM page or SCAM or PFS page. That's the best part about 22 version. We don't see anything at all. So that's the enhancement in this 22 version. But before I commit to that, what I want to do is maybe we are not catching something in this SSMS. So let me also show you very quickly on Perfmon. Maybe there is a slight contention here for those page latches. Let's see if we are missing anything. So what I want to do is check performance real quick for 22 version. Let's see. So this is 22 instance. Throughput is high up here, and page latch. Wow, it's just sleeping. It's not even there. Okay, so it has nothing. So you see the graph between 19 and 22. You will know the difference. Even after adding 4 files, you see how the contention is here for object allocation, and here absolutely nothing. So that's the best part about 22. You will not see object allocation contention in 22. We don't even have to take any action. Okay, so that's the difference between 19 and 22 version. Let me pause this here. And I would like to show you one last thing about the importance of caching temporary objects, regardless of the version. Let this be 19 or 22. I want to quickly show you this. So this is the same stored procedure that we have been using for our demo now. So this is the same stored procedure. So you see how we are creating the index inside. We are not altering the DDL and all these good things, which will help the temporary object to be cached. What I want to do now is run this stored procedure in a loop for 100 times and do this 10 times. First time, run this 100 times. And second time, run this 100 times. So for 10 times, keep iterating this for 100 times. And what I'm using is run the stored procedure, turn the counters on, temp tables creation rate counters using the DMOS perfmon counters. So once you turn this on and execute this in a loop, we should see how many temp tables are being created. So this ran for almost 1,000 times, right? So which means only one table is created. So that table, it was able to cache and it has been reused. So that's why the next iterations, we see only 0. Now what I'm going to do is alter the table, this temp table, intentionally bring this index outside of the table definition and create the index. What this does is it is altering the DDL, which means it won't cache that temporary table. So it can't be reused. So every time it has to keep creating new temporary tables. Let me go ahead and run this. Okay, so this is the one. It cannot be cached. Let me run the same thing, the 110 times iteration, turning on the counters. Let's see what it does when the temporary table is not cached. You will see. Oh my God, look at this. So 100, like every single time for the 10 times, it created 100 tables, which means 1,000 tables. And last time when we were able to cache, it was just one table and then it reused every single time. But in this case, it's because we altered the DDL and it couldn't cache it. So it has to keep creating the temporary object every single time. You can imagine the number of page latches it must have created, or the resource it must have used. So this is how contention occurs. So these are simple ways that you can mitigate the contention by tuning your queries. Well, there are many different ways of tuning the query, and that will be another session, but I just want to show you the importance of caching the temporary objects. All right, I hope that that makes sense. Back to our slide deck. All right. Okay, so the three types of contention that we saw are in summary. I just want to show you quickly here. The first one is the object allocation contention. When you see page latches on PFS, GAM, and SGAM pages, then it's object allocation contention. And what's the resolution? You create multiple data files, keep increasing in numbers of 4 as needed, create them with equal size, equal auto growth. And the best way to get rid of this contention is to upgrade to 2022, and then you're done. With metadata contention, you will see page latches on system object pages. And how do you resolve that? Do not explicitly drop the temporary objects. Do not alter the DDL. Try to cache them as much as possible. If you want to create the index, create them in line with the table definition. Wrap the temporary objects inside of a stored procedure or a function. And you can also make use of this feature, which is in-memory TempDB metadata feature. You need to restart the service when you turn this feature on. And that is available only in 2019 and 2022. And the third part is the temp table cache contention. If you see this, call Microsoft customer service like this guy does, because there's nothing we can do about it. Okay, so Microsoft can help you with that. And going back to this one, so why do you need to learn about TempDB contention? You see the slowness caused by the number of page latches that is created. So to mitigate that contention or mitigate the number of page latches, you need to understand what TempDB contention is. Only then you can go troubleshoot that slowness. And speaking about concurrency management, So you have thousands of concurrent transactions running on TempDB, and how do you manage them effectively? By creating more number of data files. So that will help with this concurrent transactions, spreading them onto the data files. So to do that, you have to really understand what TempDB contention is and how to spot it and fix it. All right, so this brings us to the end of the session, and here are some very good resources that you can take a look at. Any questions?